Hello everyone, my name is Tanmay Sarkar, and in this project I'm demonstrating a serverless microservice-based web application deployed on Google Cloud. So our project objective is to develop a serverless microservice-based web application on Google Cloud that uses an AI traffic prediction model to monitor resource usage and improve autoscaling efficiency in real time. The system is designed using microservice architecture and Google Cloud serverless services and event-driven communication using pubs and sub. Now I will open the project architecture diagram. So the architecture of this system consists of several components. You can see first we have Spring Boot backend microservice application, which receives API requests and log traffic information, which runs on the cloud run and has H2 database. And there are several services I'm using: user services, traffic services, analytic services, and second one, this traffic data is sent to Google Cloud PubSub, which works as a real-time messaging system. And next, an analytic or subscriber services. You can see the streaming events, which receives the streaming events and process them. The system also includes an AI prediction service built using Python, which predicts incoming traffic load based on the historical request data. So I have also included a scheduler method. So after getting the response from the traffic prediction AI model, depending upon the predicting load, it give numbers to the instances, and it generate instance count, and that is how auto scaling system happens. Finally, the result can be monitored through Google Cloud monitoring tools, using allowing us to observe scaling behavior and system performance. Because the application run on Google Cloud Run, it automatically scales up or down, but the prediction model also provides the significant amount of decision about making auto scaling event. Because when the predicted load is given, scheduler automatically calculates the average data during the 10 second, and upon the data, it assigns the instance count. Now I will open Java microservice application. So here you can see in the traffic subscriber, it has URL, predictive model URL. So predictive model URL is situated here in application properties. So this is the URL it's trying to access. Then it's sending traffic response time, status, hour as request to the URL. And after receiving the data from the response from the API, it saves the data in the H2 database. You can see. So I have a scheduler, the scheduler method. In this scheduler method, after getting the predicted load from the repository, it calculates the average load, get average. You can see this in the get average prediction. You can see top 20 predictions are listed, and then out of this top 20 we are getting the average, and by this average the instance count is assigned. So then scale cloud run method is called. Then it writes the command along with the instance count in the cloud run environment. So API endpoints are here. The API URL, you can see local test API URL, and this is the API URL for the client. So this is given because when simulated traffic will be accessed randomly, traffic will be set randomly within 50 to 100, and this response time will also be set randomly, and the hour also be set randomly, and after this a random predicted load will be generated, and the same method will calculate the predictive load, and according to that after 10 second it will assign the instance count, and autoscale event will happen. Here is the 10 second, it's in the millisecond, you can see. I am also getting matrices services. So matrices services actually fetches the data response time and endpoint usage and descent request. This data going from the application as a request. The header and also its details are provided here. In the dashboard service, several components are given, so that in the prediction controller dashboard service build, this link can be accessed. This is an API which is accessed by the dashboard. So in the pub sub publisher class, you can see there are two methods. From one method I created one topic, traffic topic, and another one I have created subtopic, subscriber. Subscriber from there. So when the backend service receives a request, it publishes a request a pub sub topic. Uh, a separate subscribe service listen to this topic and process the incoming event. So if I open Google Chrome, here in the topic section I can see the traffic topic is already created, and under the subscription tab we have traffic sub. So this is the subscription. uh, it will give us how many subscription and how many traffics we are getting for one link. This design ensures that the system is loosely coupled, scalable, capable of handling high traffic loads, and also it enables real-time communication between microservices without direct dependencies. So this system also includes a traffic prediction model built using Python. So this is the application I have built. This model analyzes historical request data and predict the future levels. This is the sample data, historical sample data, and according to the this it predicts the load. It trains itself first, A simple machine learning algorithm such as a linear regression is used. The prediction service receives traffic data from analytics service, and here you can see predict and gets the request from the backend. So in the backend, so yeah, here you can see this is the URL, and these are the data we are sending to the Python AI predicting model. And after getting this information, it generates predict load, and this predict load is saved here, and according to that auto scale happens. So based on this prediction, the system can also be can also estimate whether the infrastructure will need to have more resources or not. So all microservices in this project are deployed using Google Cloud Run, which is a serverless Google Compute platform. In this project are deployed using Google Cloud Run, which is serverless compute platform. So here there you can see I have created two folders, traffic API and traffic prediction. In the traffic API I have microservice application, and I have created a React.js application which is supposed to be the dashboard. So I have included that application in the microservice application as well. So in the traffic control, the application exists, jar application, and in the so, in the predict app and the jar application exists, and in the traffic prediction I have this app.py and Docker file, which is the traffic AI application. So this is the application. You can see the Python AI application, which is using UVcorn package to run. And Docker file is also uploaded over there, and according to the Docker file, the application is installed in the container. So this means that when traffic increases, new instances are created, and when traffic decreases, unused instances are shut down, and reducing infrastructure costs. This dynamic scaling is the key benefit of using serverless cloud architecture. And uh, there are several other components as well we will also look at. So after this, I will open this application link. This is the dashboard. You can see the total prediction, average load, latest load, minimum load, and maximum load is given over here. Just because I have tested this earlier, these data are present. You can see API response time trend here, endpoint usage as well. As of now, analytic dashboard link is using mostly the service of the application. So this is why we can see the rise. So previously I have fluctuated generated 100 traffic. So this is the button to create 1000 traffic, and by which auto scaling event happen. So after clicking this will create a pressure on the CPU, and it will automatically, you can see the rise response time in the trend. There is a delay, and in the matrices you can see there are two services are running. One traffic API microservice application, another one is the Python application. So for this one, in the matrices we can see the container instance count. So yeah, after clicking on 1000 traffic request, it's significantly using instance count. Like right now it is using 5. So this is how we can see the auto scale event has happened in the serverless environment. And this is the link which will be accessed by the client. So whoever the user is, if they click on this link, one traffic will be generated, real-time traffic will be generated, and this will be sent to the API, and based on that traffic will be generated and auto scale event will happen. In conclusion, this project uh, demonstrates um, how serverless microservice real-time messaging AI prediction model can be combined to build an intelligent cloud monitoring system. Okay, the system is up. The architecture allows efficient resource management, automatic scaling, and real-time traffic analysis. This approach is applied in a large-scale cloud system to improve performance and optimize infrastructure usage and cost. Thank you.